Amazing. So welcome to the Lifetime Achievement Award ceremony for Professor Branner. For those of you who don't know me, my name's Jesse Johnson. I'm honored to be the MC tonight, so thank you. And just a little bit about myself. I was Professor Branner's graduate student from 1999 to 2004. And getting ready for this event, just thinking back, about my memories there, one of my fond memories, I think, from that time was my evening meetings with Professor Branner. So we always would meet in the evening. I think you guys know about that. But it was so fun to meet and talk about research and talk about my dissertation plans. But we would always start off the conversation talking about football. So for those of you who don't know, Professor Branner's an avid football fan. You probably all know that, but he's a diehard 49ers fan. 49ers. And for those of you who don't know, as chance would have it, I also played on the UC Davis football team as an undergraduate. So it gave us a lot to talk about. And then, to extend on that a little bit, I feel like football is a pretty good analogy for the way Professor Branner approaches teaching electromagnetics. UC Davis football, that's right. I feel like it's a good analogy for the way Professor Branner approached teaching his students electromagnetics. You know, the best football players are skilled at the fundamentals of the game, like blocking and tackling and being in the right position at the right time. And that's kind of a reflection of Professor Branner, who always works so hard to teach his students the fundamentals and give them just a really solid base to build a career upon. So I'm just so thankful and so glad to be here. And let's kick off the program. So first we have Stephen Rosenau, the General Chair of the IMS 2025, and Jay. Why don't you guys come up?
Although in this case, I'm actually not here as the General Chair of IMS 2025, although I hope you are enjoying that, but rather here as a former student of Professor Branner. And I really have to say, he touched so many people's lives in so much of a positive way. He provided advice, he provided guidance, he provided education. And not all professors teach. He definitely taught. As a matter of fact, I remember one time, forgive me, but I'm going to tell a story. Those of you who know me, I always have a few stories up my sleeve. But the first story I'm going to tell is, and yeah, I'm going to tell two. The first story is I'll keep them short as best I can. The first story is when we were sitting down in one of the graduate level electromagnetics courses. And as you may know, electromagnetics, when you get into the graduate level, it is mind-bendingly hard. Understanding comes painful and slow. And Professor Branner, I remember one particular session comes to mind where he walked in. He put an equation at the top of the board. It was one we were familiar with because we had previously derived to that point, to that equation. And he put a box around it, and he started working through the formulations. And he walked us through, over the course of a 2-hour lecture, he walked us through a derivation. We all understood. We all walked out with a clear understanding of this derivation. And at the bottom, at the end of the second hour, he put a box around a second formula. And he said, now, of course, in Jackson, he simply goes from the first box to the second box and says, this can be done with some simple derivation. When we walked out, we actually understood what Jackson claimed was done from a simple derivation. If we had simply been trying to read it from Jackson, we would have had no hope. But he took the time to explain it to us, to make us understand. He brought enlightenment to us. The other story I'd like to tell is actually from the undergraduate class, 132, the microwaves class. I had come into his course, and I took the undergraduate class, even though I was coming in with a master's degree. By the way, to be clear, Professor Branner was my master's advisor, for which I'm deeply grateful for his advice and recommendations. But I went on to get my PhD as well, so I hope that my success has I believe that my success, rather, has been partly due to his encouragement in my master's degree. But in 132, we came in, and I had come from, I'd actually taken a break from school and gone out into the industry and worked for a company called Watkins Johnson for a while. And I'd learned how to do things, strange and bizarre things like, wire bonding and trimming filters, which is a somewhat arcane art, which may or may not be well known anymore. But we made a bunch of I think it was coupled transmission line filters, and I took this filter, I manufactured it in the little strip line system that he had in the dark room there. All those lovely chemicals. And I took it out and I put it on the HP 8510 Vector Network Analyzer. And yes, I'm showing my age with that. And I looked at it and I said, oh, well, this isn't right. It didn't have the right kind of passband, right? So I sat down and I immediately grabbed a little bit of copper tape and an X-Acto knife, and I started carving away. And I went to town on that filter, and I was working on it. All of a sudden, I noticed that everyone else in the lab was staring at me. And I went, uh-oh, did I do something wrong? And the TA says, I don't think you were supposed to do that. Turns out the intention of the lab was for you to build the filter and demonstrate that when you build a filter, it doesn't actually work out the way the theory says it will. And in fact, you're then supposed to turn around and measure it carefully and then re-simulate it and show that the simulations actually track to what you built as opposed to what you designed. That was his intention. I kind of blew it because I was trimming my filter. So I was sort of terrified, and I'm going, oh God, I'm going to get a bad grade on this lab, and I really need to do well here. So I went to Professor Branner, and when I explained what I had done, he started to laugh in a positive and jovial sort of way. And he says, he could tell, I think, I was panicked. And he says, don't worry, it's okay. Just write up what you did, explain what you did, and why you did it, and how you did it. You'll be okay. And I did. I wrote it up, and the reality is, technically speaking, I failed that lab because I didn't do what he asked me to do. But he understood that I understood what his intention was. And so he gave me a good grade anyway because he was willing to take the extra effort to meet me where I was coming from, even though I wasn't the typical student with a typical approach to things. He met me where I was coming from, recognized that I understood what he was trying to teach me, and accepted the work that I had done. He validated me. And for that, I am deeply grateful. He was willing to take us where we were and teach us and bring enlightenment to us. Thank you.
Okay, so I wasn't fortunate enough to have Professor Branner as my professor, but what I do want to say here, I just wanted to take a couple of minutes and just say that his influence through his students in RF and microwave reach far beyond what he's been able to do within the academia environment. I was able to interact with Professor Branner at a couple of conferences in San Francisco in previous years, but that interaction, his enthusiasm was contagious. And seeing an individual like that and his interaction with his students was something that I was deeply impressed with. I actually approached Professor Branner and I said, I have openings here at Northrop. I'm looking for individuals who are enthusiastic about RF microwave, and I think what you've taught your students is something that really helps. So anyway, I just wanted to say that even though I wasn't one of his students, his area of influence extends far beyond his students, in fact through his students. And that's what really gets me. So thank you very much, Professor Branner.
Thank you, guys. Thank you. Next, we have Darren Phelps. Darren is with Keysight, and he's also the local IEEE MTT chapter chair. So he's going to give the official local chapter introduction.
Thank you, Jesse. Yeah, so on behalf of the local chapter, which is the Santa Clara Valley chapter of IEEE and the MTT, I'd like to welcome you all tonight. We're sponsoring this event. We thought there was no better time to do it today with IMS Week. We have basically experts of microwave from around the globe in San Francisco now, and there's no better time to celebrate and honor Professor Branner than now. This is the perfect time with the influx of the knowledge, the talent, and people. We have a lot of his past students here from the past. I guess I feel grateful to work with so many of his past students. I thought there might have been a coupler design problem handed out the door. I was scared. I thought there might be something here to solve this, but I'm glad there's not. But it's so great to see so many faces that I know. So on behalf of the local chapter, you're now honorary chapter members because this is officially one of our chapter meetings that we're holding. So thank you so much for coming, and we'll continue on. Thanks.
Thank you, Darren. Thank you. Okay, so next we're going to have a couple of speakers who will reflect on Professor Branner's career. We're going to start off with Craig Branner, son of Professor Branner. He's a senior staff RF engineer.
Oh, okay, so that's good. Yeah, I had to put mathematics into it. It's very mathematical. There's not much space here. So I want to start this off by saying, and now I understand. Okay, brilliant, caring, considerate, empathetic, generous, religious, determined, supportive, ambitious, confident, honest, optimistic, logical, efficient, focused, organized, reliable, humorous, and trustworthy. However, Dr. Branner can best be described as the epitome of an extraordinary soul. And now I understand. So my father played a very profound influence on my life, and he had a very powerful influence on many others as I was growing up. So, little funny story. I remember when I was elementary school, maybe 5th, 6th grade, and it was summertime, and the kids were out playing, right? They were out playing, and my dad would say before he left for work, he would say, "Craig, go grab that math book. I want you to do 1 through 15 and have them ready and done before you go out and play." And I would say, "Oh my gosh." And he would say to me, "You know, Craig, mathematics is the key," right? And then I understood it. I remember when I started off in industry, there's some Argo system people here, I believe. I went to work in what was called MSG, Military Systems Group. And countless times, people would walk up to me and they would say, "Are you Dr. Branner's son?" And I would go, "Yes, yes I am." But what they said is, I took his 132 series. And because of him, I'm a great success. My career was a great success, or it has been. So I'm going to ask, or tell my dad, look around you. Look at your family, your friends, your students, your ex-students, your students, and your cohorts. There's not anyone in this room that your influence has not touched. And each one of us is a better person because of you. We are the flowers of the seeds that you planted along your life. And we are all immensely grateful. Okay, so now, all right, so while working on his BS degree in the around 1955 era, Dr. Branner decided to take a position at Wright-Patterson Air Force Base. And so, if any of you that doesn't know what Wright-Patterson Air Force Base is, back in the 50s and the 60s, they were very much into flight, but also new technology. And so he took this position and was in the Advanced Electronics Devices Technology Division. And he was introduced to Professor Gustav Conrad Medicus. And this was a great opportunity because this guy was well-known plasma scientist. What do we do here? So he became a part of this team.
Can you use the microphone?
Oh, sorry.
Sorry.
And he, wow, Jesus. This is really good. Yeah. So he became a part of this division and a part of this team. And they really needed an electrical engineer that had knowledge with designing amplifiers. So he became a part of this team, and I always like to read this line here. It says, his research team, talking about Professor Gustav Conrad Medicus, was led by the electrical engineering efforts of George R. Branner, and he introduced the second derivative development system. So he became part of this team. I know. Oh, by the way, there will be a test later. Nope. No, yeah. So, open notes. So, I'm joking. So he interfaced his amplifier design within this plasma system. And the whole idea of this system was to automatically plot these probe curves on an XY grid. And it turns out that his amplifier was, I like to do this, so perfect. Right? And because it was so perfect, the project was a huge success, right? And Dr. Medicus was extremely pleased. So sometime shorter, he finished the project in 1959, and that included doing all the extra research and writing the paper and all this kind of stuff. And then it was actually published in 1963. By the way, during that time, he completed his Bachelor of Science degree, and he started his master's and completed his master's at the same time. This was a great achievement for him because it kind of catapulted him into a lot of other things in his career. So a couple years later, he was invited to teach at AFIT. And AFIT was a kind of an institution, like a college institution, that if you wanted to continue on with your education, then you would go here. And he became a teacher there, and he was teaching the basics of electromagnetics. Is there anybody in the room that knows electromagnetics? I'm sure. So anyway, he did that, and he was also still a full-time employee at Wright-Patterson Air Force Base. Sorry, my mouth gets dry when I talk. So what happens? He gets his education there, and he catches wind of what's going on in Silicon Valley, in California, and all the great schools and all the great companies and all this kind of stuff. So he decides to uproot the family, and all of my family can admit to this. And he went to a company called GTE Sylvania. And I know several of you here know about GTE Sylvania. Yes, Jeff, I know. So he was there, And I just like to show this picture of this bubble. I think they were doing antenna testing inside this bubble. I could have shown the buildings that he worked in, but what I remember is as a small kid driving by here and seeing that bubble. And so I was like, wow, what's going on with that, right? So he worked there for about a year and a half. And at this time, he started his PhD studies. So after about a year and a half, he went to ESL. And I was really proud. Dick and Harvey, can you guys stand up? Stand up. Can you stand up? Stand up. So I'm not exactly sure how this story goes, but they came together. He was working at ESL. They worked together. And the reason why I have them standing up is because when we were kids, we got to go to a couple of dinner parties and parties with Mr. Keenan and Mr. Yee. And so I just out of chance, what I did is I went on the internet and then I found his number. And I'm like, wow. So I told him that, hey, this big function's going on, right? And he was really excited. He was really excited, and he was picking up Harvey and I think yesterday, right? Was it? Yeah, was it yesterday? He was picking up Harvey, and he called me back and he says, I have to be there. I have to be there. And I said, great. So I just want to make one quick mention of the gentleman that's in the middle. That is Dr. William Perry. So I bet you a lot of people in here don't know who he was, but at the time he was, I believe he was the president of GTE Sylvania. Oh no.
Yes.
No, I know he was ESL. I thought it was GTE Sylvania too. Awesome. That's what it says. Anyway, anyway, so this is Dr. William Perry, and so all these guys, worked under Dr. Perry, who ran that particular company at the time. And what's important about Dr. Perry, or what's extra important, he became the Secretary of Defense for the United States. I believe the years was 94 to 97 under the Carter administration. Boy, I had to do my homework if I'm going to give a presentation, right? So I'm gonna say just a little bit more about him a little bit later, but I just wanted to let you guys know who he was. So when he got to ESL, he was under Paul Scheibe, which was under Professor Edward Meyer. And Paul Scheibe decided to teach Professor Branner all about optimization theory and using the Dirac notation in solving nonlinear least square problems. And so you know what's really funny? I went in and I looked up these theorems and I go, I have no idea what's going on there. But as you can see, it was very complex. And so he actually learned these skills he went over to Paul Scheibe's house at night after dinner, and they sat on the couch for hours. And Paul Scheibe taught him this theory. And so I just threw this up here to scare everybody. But this is what it was, and this knowledge of optimization using this theory carried my dad through for the next 40 to 50 years. He used this technology. So one of the very first things, and I know I'm long-winded here, but one of the very first things that he worked on was a special LNA. We're calling it a restricted amplifier project. Let's just leave it there. And so he was at lower frequencies, and I know this is a little bit technical, but at lower frequencies, bandwidths reached as high as 20%. Okay, just leave it at that. without the, you know, I had, believe it or not, I had to have my dad explain this to me, so, you know. So, anyway, so he was challenged. He was actually challenged with bringing the bandwidths up to double this amount, up at a higher frequency. So there was a huge challenge there, right? And so what he did is he came up with an idea of this matching network using a pumped varactor. And I'm not going to read the bullets, but you can see the plots on the side. He was able to achieve this with his optimization techniques that he had learned just recently from Paul Schreiber. So what happened was is that it was a huge success. In fact, it was so much success that the customer invited only him out to Long Island. I believe you took a train and right? And he went out to Long Island and he presented his information again, and they were, did I do this before? So happy. They were so delighted that he had done this. Nobody had done this at this time. So it was cutting edge at the time. Oh, by the way, it was published in the IEEE also. Okay, so he's at ESL, and they're starting on this project, this antenna project. And what happens is during that time, TRW, I know a lot of you know TR, decides to buy ESL. And the government said at that point, you can't work on this project because they had certain stipulations. So Meyer went to Argo Systems, and he was at Argo Systems at this time. And somehow, through the back channels, he let Dr. Branner know that this project was happening, and he wanted to have Dr. Branner work on this project. So, and I know a lot of us have been in this position, like you're working at a company and somebody else offers you hey, we've got this over here, you know. Well, he got very excited about the project. And so what happened was is that he basically went there and he started on this project, okay? Now, this project was actually, and he described it to me, the actual antenna for the customer was 20 by 30 feet. It was huge. So it was up to Dr. Branner to create a miniaturized version of this. So he designed the antenna, and I just created these pictures here. So this is not exactly how it was, but just to give the crowd the idea of what actually was happening. He had the antenna built, and he had it mounted on building 2. And by the way, I used to work in building 2 too. So, and then he had a transmit horn over in a different building, right? And so what he did was he took all these measurements, a ton of measurements, and what happened was he needed to remodel what he had designed. So he used his optimization techniques, and he remodeled it. And what happened was he after remodeling, they recreated the antenna, and then they did the measurements, and again, they went perfect. Okay, and so at this point, the model was considered a very accurate model, and it was very successful. So that information went to the customer, and then after it goes to the customer, what happens is the customer just loved it. And so because of that, the customer came back and provided Argo Systems with a 3-year contract. Don't worry, guys, we're getting close. I see some heads nodding. Okay, so as it would have it, Dr. Branner's over at Argo Systems, and then somebody over at his old company, ESL, which is now a subsidiary of TRW, says, "Hey, we've got this project. We've got this this project. I think you would be very good at." And so what happens is Dr. Branner made the jump back from Argo Systems to ESL, so to work on this project. Now, this project was basically they were building a room, like an EMI room, and the internal portion, the materials, and the external materials were chosen by the government. They wanted him to test this this EMI chamber, basically, right? So what he did was he built a 4x5x6 prototype model from specified predetermined materials, and he basically had it built. So he uses these materials, he has it built, and he has it taken out to, and here again, this is one of Craig's pictures, right? He has it taken out to the outdoor lab area, it's basically out in the field. And then he has to take all these measurements on it. And so he had to radiate this box from several distances and different frequencies. And so what he found was that the box wasn't all that good, right? It wasn't all that good. So during that time, hopefully I say this right, another government agency, which was also in the same area, they also they caught wind of this. And so what they did is they had another company build an actual room. And so they wanted Dr. Branner to go out and actually do the testing on this room. And he had two test engineers working with him, and they had made it to the site, and they decided to go ahead and start doing some testing and setting up and all this kind of without my dad. And so as it turned out, one of them was inside the chamber and one was on the outside of the chamber, and they were talking on what I believe were like walkie-talkies at the time, or radios. They were talking, and so the door was closed. The guys inside the room, and they're just communicating. Yeah, well, cable. Yeah, we've got that cable. Yeah, and so what happens is it doesn't work, right? It's obvious it doesn't work. So what happened was the research went on, and he did all the measurements, and that information went to the government, and the government was very pleased because it proved what they were using was not adequate, right? So this is one of my last pages. You guys are clapping. Yeah, thank God. This is one of my last pages, and this is really kind of dear to my heart because my dad worked so hard. I get sentimental. My dad worked so hard. He loved to teach. And so back in my brothers and my family can really remember this, right? Back in the early 1970s, he became an assistant professor, 50% of the time. And so what happened is he was working full time at ESL, Argo Systems, whatever company it was, right? And I always remember it, Mondays, Wednesdays, and Fridays, he would work at one of these companies full time. And then on Tuesdays and Thursdays, what would happen is he would go to work early, and he would leave from work around 11 o'clock. Around 11 o'clock, he would get on the freeway 105 miles. He would teach his class, have his lab hours, and then he would come back later on in the evening. He did that for almost 16 years, right? 16 years. So in closing, what I want to say is that he wanted to become a full-time professor. And so the colleges at that time, to become a full-time professor, you needed recommendations. So as it had, what happened was he actually ran into Dr. Perry's assistant in an elevator. And Dr. Perry told him, hey, you know, you guys were doing, and these guys too, you guys did such a fantastic job that he would like to show his appreciation, right? And my dad said, he said, could you ask Dr. Perry to write me a recommendation letter so I could become a full-time professor? And so that's what happened. That's the story. And so with that letter went to UC Davis, and then like a year or two later, he goes to work full-time at UC Davis. So kind of the moral of all that is this is one of the hardest working individuals you'll ever want to see. Up at hours, crazy hours. I always tell my mom, is he asleep or what is he doing? No, he's you know, he's gonna wake up, he's got it, you know, all this kind of stuff. So anyway, that's kind of the story for this. And so I'm gonna close with this. I wrote that a couple of years ago during the pandemic, and I want to say this. You know, some would say that Dr. Branner is mainly known for his, you know, what he created, the 132 series, that teaches kids basically the basics of RF engineering, right? And so to those people, I say, no, that's not it. You missed it. That's not it. Dr. Branner is much, much more. He is about the dedication to his professional career, yes, but he's also very forward with the sanctity of his religion. So there's more to it than just 132, right? And then also, he is really also about the promise of his inner peace. And finally, he is, most importantly, is the solitude of his family. Thank you very much.
Thank you, Craig.
Yep.
Craig, all I have to say about that speech. Next, we have Kelvin Yuck. Kelvin is the founder of Echoic Engineering. He's going to continue this this segment on career reflections. Also a UCD alumni. Come on up, Kelvin.
Give me 1 second to get set up here. Is this how you do it? What am I doing wrong?
It's working. It's working.
Oh, it is? Okay, there's multiple screens on it. Okay, got it. Okay. Okay, so as you know, a lot of hard work and energy was put into this session here, this event, the ceremony for Professor Branner. So I didn't have much time to practice, but I do have a speech prepared. So please bear with me. Professor Branner wanted me to talk. Okay, yeah. Okay, gotcha. Now, Professor Branner wanted me to talk about his baby, 132, the course at UC Davis, and I will be doing that. For those of you who do know me, my name is Kelvin Yuck, and I was Professor Branner's PhD student for many years. And he finally signed off on it. So that's why I'm here today, to celebrate with you his lifetime of achievement. So the 132 RF and microwave in wireless communication series at UC Davis is Professor Branner's most cherished creation and has served as a launch pad for future leaders in wireless technology for many, many years. Tailored for undergraduates and early graduate students, it builds strong fundamentals and hands-on skills in designing, modeling, and testing next-gen RF and microwave systems. All right, so let's get started. Script E is the electric field intensity. Okay, so I won't actually go into Maxwell's equations tonight, all right? But I did want to show Professor Branner's famous notes, the beloved notes of Professor Branner, that we all learned to love his handwriting. And one of the most important fundamentals that he taught us was the Maxwell's equations. So here they are in his own writing. But for the rest of the talk, I will emphasize more the lab and the practical portion. So Professor Branner, he ensured that 132 blended theory with practice using Maxwell's equations as the foundation for that experience. For those of you who took 132, let's take you down memory lane. 132A covers static electric and magnetic fields, material interactions, scalar potential, and Maxwell's equations. It also introduces plane waves and lossless transmission lines, all fundamental concepts for advanced RF and microwave studies. In the lab, students explored real-world applications, beginning with Lab 0, right here, where a dish antenna system, complete with feed and LNA, was used to downconvert a satellite signal and produce a live TV image. So this is the... So what you're seeing on screen here is actually the roof of Kemper Hall, where the ECE department resides. And Professor Branner has his own story about how this came to be, this dish antenna. But this dish antenna was built when the building Kemper was built. And with Professor Branner's input, they made sure that this dish antenna was made available for research and education. And at the end of the dish antenna, you can see that there's an antenna feed and LNA right here, which is essentially exploded here, exploded view. And that LNA took the signal that was captured from the dish antenna and routed it through into the down conversion system, as you see here, and then displayed on screen. So this was a very, very challenging lab, and the TA had to set it up, all right? And the most difficult part of it is trying to aim into space this dish antenna, okay? Because there's actuators, it could rotate, it could pivot. So for those of you who saw this Lab 0, who was able to actually get a picture on the screen, that was an amazing achievement. The course also introduced the Scalar Network Analyzer, providing students with hands-on experience in characterizing various waveguide types from rectangular, circular, and parallel plate, as well as components like horn antennas and directional couplers. So if you take a look here, we have the traditional setup here for those people here from HP. We've got the 8757 Scalar Network Analyzer set up on a lab bench for 132A. We've got the slotted line and the circular waveguide. And with this setup, we were able to test a myriad of waveguide structures, including parallel plates, horn antennas, and waveguide couplers. Now, 132B focuses on the design, fabrication, and testing of key passive RF and microwave components. Students gain hands-on experience by fabricating their own microstrip circuits, from photolithography to etching to soldering connectors, culminating in functional devices such as filters and couplers. And so for those of you who did take 132, you will remember this very awesome place here, which is the dark room. Okay, that little closet that was built into the third floor of Kemper to accommodate all of this. And you can see that you do the photolithography with a mask, and then you etch the copper right here. And then after that, you would attach your connectors, your RF connectors. Well, actually, first you'd get the circuit itself, and then you'd attach the RF connectors in the assembly bench. And this was kind of the gold standard for what we did to build a practical circuit. Importantly, students were introduced to S parameters using the 8510 Vector Network Analyzer, the VNA workhorse that continues to serve microwave needs to this day. So Professor Branner was always very fond of his three 8510s here, as you can see. And for those of you who did take the course, probably spent many hours in front of these instruments here, using copper tape, right? And using X-Acto knives and trying to get that bandpass response right where it's supposed to be. But I have good news for you. They're all still there, okay? They're still operating to this day, okay? And still bulletproof machines that serve its purpose even now. So if you even talk to a 2025 132 alumni, they will tell you all about the 8510. (132C) introduced students to active RF and microwave devices with a focus on stability, noise, and system-level integration. Students learned to characterize transistor behavior, both DC and RF, perform de-embedding measurements on packaged transistors, and applying these skills toward the design of small signal amplifiers. And if you take a look here, if you're familiar with this one, this is a curve tracer 4145, and that's what we use to take the IV characteristics of the transistor, the active device. Up here you can see that there's the test fixture which was used to house the packaged device with bias networks attached. The second way that we utilized to test the transistor was to build a board, to build a simple 50 ohm transmission line interface board to that packaged device as you see here, and then attach that device via soldering and then measure it. Now, one of the key things that Professor Branner always emphasizes, you must de-embed that fixture. And so we learned how to do port extensions to extend the plane of reference to right where the transistor is to get the transistor S parameters. And with that, we were able to design small signal amplifiers. As you see here, small signal amplifiers being measured right here using a Keysight E8364B PNA. Additionally, students learn to distinguish between linear and nonlinear power behavior through single-tone and two-tone intermodulation measurements. So what you're seeing now are some of our 132 alumni who may even be in this room. Jeff, are you here? Curtis? Yes, Jeff Curtis, right back there. Okay, who is now working at SpaceX, right? Okay, so this is our beloved Jeff Curtis, and he's here doing single-tone power measurements on that transistor. So this is the setup here. We use the spectrum analyzer and the signal generator right there, 832A20A. And this is the 83, or what was that? I forgot the number right now, but yeah, spectrum analyzer. 8565, right? 8565, yeah. Now what we have here is the two-tone measurement setup. And as you can see here, we have two signal generators going in and combining the signal to produce the two-tone test, right? The classic test for testing linearity. And what we can see is that that is being fed into the bias network and then to the test fixture here, transistor test fixture, and that's biased both at the input and output, and the output of that is fed into the spectrum analyzer at the end. And here's a zoomed view. There's two isolators where the signal comes in, and then those are power combined and then fed into the bias network, into the test fixture, and out of the other bias network. And now Professor Branner always emphasized these two components here, the isolators. And so he always believed that it was important to use isolators to prevent reflections from the device going back into the signal generator. And finally, Professor Branner was always very proud of his anechoic chamber, which itself has a very storied legacy. And I've sat with Professor Branner for many hours hearing the story of how this came to be. many hours. So, and if I remember right, it was there and they wanted to get rid of it. They wanted to get rid of it because it was an eyesore of a kind.
Yeah, at Davis.
Yes. But they did some things and they managed to beautify it And it stayed. It stayed, yes. Professor Branner's wife, I think, was in charge of beautifying this anechoic chamber. So there's a market for beautification for test instruments. Right. But you can see here we've got the anechoic chamber, and this is the interior of the anechoic chamber here, with some components attached to the rotator here. And on this end, we've got another 8510, which is responsible for taking those measurements. So this anechoic chamber was used for many, many years and is still in use for measuring antenna pattern and gain. And so I just want to say that 132 encapsulates a solid legacy of unending resolve for excellence. And we have Professor Branner to thank for that. A lot of times, a student will ask me, what should I choose for my emphasis? What should I choose for my major? Should I do RF or something else? And it's a very personal choice, and really the answer only lies within. But for those of you who have chosen to take that journey, I think the answer lies in this room. Take a look around you at the people around you who are connected through Professor Branner's program, and the answer is a resounding yes. You did make the right decision. We live in a time when knowledge comes from many sources, and while that can be a good thing, it also brings uncertainty. For all we know, the education or the future of education may not even come from the teachers that we recognize. It may come from AI or some other tool. But never forget, there was and still is a time where we learned from people. Remarkable people like Professor Branner, who inspired us to grow, gave their heart and soul to their students, their programs, and future generations. So as long as you remember who you are, where you came from, and you keep those incredible individuals close to your heart, you will find the strength to keep going, to overcome challenges, and to move forward with purpose. Thank you. Give me 1 second. 1 second.
That's great.
My phone is acting up on me. Okay. Wanted to show a couple of final slides here. These are some students from the class that I did TA for many years. So here's Professor Branner among us. And if you're in the room, please stand and be recognized. Professor Branner students. 132. Yes, oh, yes. All 132 students, please rise for Professor Branner. All right, thank you very much for doing that. And now I would like to do the honors of welcoming our first guest speaker, Jin Baines, a man who needs no introduction and one of our greatest successes of 132. I want to personally thank him for being here to celebrate the lifetime of work that Professor Branner has given to the world. But before Jin Baines takes the stage, I also want to touch on another 132 topic. As you may know, one of the things Professor Branner always drives hard on is that you must take good data. You must document your work, and you must write an excellent lab report. I have one here with me, and this one is certainly no exception. And because I am the eternal 132 TA, on behalf of 132 and Professor Branner, I would like to break with tradition, because as you may know, nobody ever gets their lab report back. So I want to share this special gift. Jin Baines, I have your lab report. Here it is, and I would like to gift it to you, as I said, on behalf of 132. Thank you, thank you.
Never thought I'd see this again. Go back and look at it. Yeah, please. This is special. This is emotional and personal. So it's really, really appreciated that I was invited to come give a talk here. Suresh made sure I was going to be here. I was going to be here. I had to come to the event, as it is. Typically come to IMS. Lots of reasons to be here. San Francisco is always special, but you know the schedule's packed. There's so much going on. But Suresh made sure. He said, "Hey, we have a special event happening," and so for me, it was like, "Yep, get all the other stuff off the calendar. This is where you have to be." So super nice to be here, and super appreciative of everything Dr. Branner has done for all of us. I mean, this is an incredible group of people that have come together here, and you know, you just feel great to be part of this group, actually, because there are people here that I don't personally know, but we're all connected in a special way. Progeny is a word that comes to mind. I'm not sure if it's the right word, but effectively there was some of the charts that Craig was showing, the lineage. It goes back way before our time. We're all sort of somewhere in that story. I'm class 1994, not even halfway through Dr. Branner's teaching period. In fact, 1972 to current. Some of you might relate to this. I thought I was towards the end of his teaching career. In fact, I'm pretty sure he told us in that class multiple times that he's gonna retire soon. And surprise, surprise, he was still there. I look at Justin, who came and joined when I was at National Instruments. He came and joined me in 2008 at NI, and class of 2000. So many others who were still being taught. Just the talent, again, you know, the talent was incredible that came out of there. So the fact that Dr. Branner kept teaching was super valuable to all of us who were out in industry, because we knew there was a source of talent that was coming out just regularly, and we could keep tapping into that. Is that out of that little phone right there? So anyway, so we could keep tapping into it, and even now, we still can keep tapping into it. So needless to say, I'm really, really grateful for the opportunity to speak here. Also, just super grateful to Dr. Branner for everything he's done. I've kind of always felt like life has so many interesting sort of things that kind of happen just almost coincidentally. There's little things that kind of send you in one direction or another, and they're not even a degree of variance from where you might be heading, but they affect your life in a sort of a significant way. Coming into the US back in 1988, I just randomly happened to come to Davis. I actually randomly happened to go and study electrical engineering because I was, I liked math, liked physics, all the good stuff. Ended up in Silicon Valley in 1988 just because that's where family was when I came to the U.S. Dave Chu, my good friend, was coming in about the same time from China. I was coming in from the UK. I remember trying to figure out where to go to school, and somebody just said, "Hey, Davis is a pretty good school." And then I was trying to figure out what exactly I was going to study. I wasn't entirely sure that it was going to be EE. And so somebody nudged me in that direction too. Happened to be a guy that Dave might know, a guy named Cheng Chang. Cheng Chang was a friend of ours in high school. Anyway, he said, "Hey, you're pretty good at physics and math. You should go do this." So end up going into electrical engineering. And it turned out to be a good choice at the end of the day. It was a good, challenging field to go into. And then end up in Davis, and would I have ever thought I would go into RF and microwave design? It wasn't really a thought at the time. You learn a few things in your undergrad courses, lower division, and then somewhere along the way, stumble upon 130A, and you come across Dr. Branner. And there was something kind of special happening in that class, and you could tell there was, he had a particular way of teaching, and I think that the way I think about it is that he just really, first of all, he knew the material extremely well. He knew what he wanted to teach, but he was committed to making sure that everybody in the class was learning the material. They were paying attention. In fact, we had, he'll probably remember, because he remembers almost everything. There was a group in the back that would make some noise every so often, and I'm like, you guys are taken away from the ones that want to learn. And it wasn't something he was really going to tolerate, right? Because he was there to teach, and he didn't want anybody taken away from that. That was only 130A, so we're still early in the game at this point. There was enough there that I knew that I wanted to go on. And somewhere along the way, I came across my good friend Suresh, who happened to be taking 132 in that time frame, and it was like, the sequence is incredible, and combined with my exposure at that time to Dr. Branner, was like, I got to go do this. And the thing about 132, as Kelvin pointed out, was super difficult sequence of courses, and so you have to be committed to it, because it was clear even back in those days that this is going to be like a full-time job. And so the question was, are you willing to give up the other things that you're going to have to give up in order to make this happen? And as Craig pointed out, super hardworking. It was clear Dr. Branner was a super hard worker, but to be in that class and to be successful, you also had to be a super hard worker. It was just one of the entry criteria. So I did obviously take the sequence. Some memories come back from what was shown there by Kelvin. Those were great memories. The reports were incredible too, because we were learning so much more than just theory. I definitely gained a massive appreciation for electromagnetics, for Maxwell, for Helmholtz, for you name it, all the stuff that we learned, the wave equation. There were so many things that we were learning, and it was fascinating material, and it was great to learn. But we were learning more than that in that class. We were learning to work hard, like I say, we had to. We were constantly getting, because Dr. Branner would take pauses. I should probably adopt his style more, because I usually am out and I'm trying to deliver a message. I'm going to take a little pause here, just like Dr. Branner used to, and he would tell us life stories. And it would be in the middle of some equations and some stuff that he's actually, some course material. And so we were having a hard enough time keeping up with what he was teaching. And then all of a sudden we're learning about the 49ers, or we're learning about, which, 49ers were new to me at the time, but he knew every player, every catch that was made, and all the classic games. And so, what is it? This isn't what we thought we were coming here to listen to. But it was wonderful, and it was a wonderful story. And then he would always have things that would kind of draw you in some ways. He would talk about how magical this stuff was, and you kind of felt like you were learning something that went beyond just the equations. And so that would pull me in constantly. I really, really enjoyed the class. A lot of the exams are incredibly difficult, but he taught us how to write too. Right? And that was one of the things that I think he made clear, is that he talked about industry and career. We were young. A lot of us were young. We had a few people that came back to study. There was almost always like a couple, it seemed like, in the class that had come back, that had gone out and come back from industry. Maybe they'd heard about how great the sequence of classes was, so they came back to learn. But me going through the first time, a lot of us going through the first time, we didn't realize how important those things were. But he had been in industry and he knew what it was like out there. And so we were absorbing all of this stuff. But I mean, stuff like this, right? Who writes multiple reports like this with the myriad Touchstone, Libra simulations and plots and everything that that we were doing in the meantime. I was given the talk on Monday night, and I talked about the Smith chart. And literally, those were the days where we had the Smith chart, impedance and admittance chart, but we didn't have the ability to get color images, so we had black and white. And so the two were smeared on top of each other. And if it's hard to do it one way, it's really hard to do when you have a black and white version of this thing. But anyway, so we spent hours and hours doing this stuff, but we learned how to write reports. And if the report didn't make sense, it was going to come back to you, and you knew you had to make it better. And so the bar was set extremely high. The bar was set extremely high. At the same time, and I don't know if this is good or bad in today's world, Dr. Branner would tell us, don't waste time with those ones and zeros. and we would look down on those. We sort of had to. We were in the, we're learning electromagnetics. It was a higher level. But the ones and zeros, of course, they sort of continue to sort of take over a big chunk of the world. But we definitely thought that was just trivial stuff that really didn't need to be taught. Anybody could pick that stuff up. May still be true. In fact, if I go back to my headset back then, anybody could do that stuff. But the stuff that we learned there was really broad and really valuable. We also learned that it's really important, all you guys know this now, the ones that are here, that have gone through your careers, that you have to really take care of yourselves in your careers. Because I think it was Dr. Branner who really kind of put that message out there, which didn't latch really early at the time, but over time, because you think back to what you hear. And, he would talk about how, these companies, they don't have a sense of loyalty towards you. That's kind of the general mentality, right? So they don't have that sense of loyalty towards you. So you got to take care of yourself. And so we knew that, at least that we had heard it, whether we knew it or not. Generally, you have to kind of experience it to really get to know it. But it was important to hear it, and it was important to kind of keep it in your head. And in fact, I think about it, and look at Trang and a lot of the people out here that I've worked with, had the opportunity to work with a lot of people. So to me, it was always really important to make sure that you don't become like one of those companies, for one thing. And we always held HP up at the highest echelon because he did, right? So, and they were very, good to human beings, and they were a human kind of a company. Back in the day, things have changed. Perhaps, who knows? I'm not to judge on that. But what I'll say is, back in those days, it was the place to be because they did care about people, and they did appreciate technical knowledge, but they also appreciated the human being for what the person was. So I kind of adopted all of that too, personally, to the extent that I could. So it was important to me to make sure that I was doing the same sort of thing. So these were all lessons that we learned through the course, and that was, in many ways, just sort of the beginning of it all, in so many ways. There was a particular thing that Dr. Branner did, which I think meant a lot to me, it meant a lot to maybe anybody who was in 132, you guys all stood up. But he said, hey, you got to stick around till the end, because the most important lecture comes at the end. And so it wasn't just a lecture, it was actually a homework assignment. And it was to to watch how compounding works. Right. It was really, really important. In fact, you'll hear people today like Warren Buffett will say, hey, the power of compounding is not really understood. It's magical how those numbers go over the years. So you actually have to do the lab and write it up, put it into a spreadsheet and actually see that. And it's hard to believe that it happens that way, but that's actually how it happens. So me, plus a whole lot of other people here, were probably one of the first people to go into the workforce and say, hey, yeah, sign me up on that 401k. Right, so that was due to that one lecture. Right, so I thought that was one of the most powerful lectures. Nothing to do with electromagnetics, but power of compounding maybe has to do with everything in the world in some ways. So it was super valuable. The other thing that Dr. Branner did which was unique also, he spoke about HP as sort of like this glorified company, which was like really at the top. He protected any HP gear like it was his child. and Craig can say if it's relatively the same or not. But you saw the 3 8510s up there. And the first set of courses you take with Dr. Branner, he doesn't let you anywhere near that stuff. You don't get to touch it. You have to earn the right to touch it. First, you have to show that you actually have respect for what you're learning and for connectors and cables. And last thing that he's going to let anybody do is damage his 8510. And so it was actually, just a privilege to finally get in front of the 8510. And it was earned, rightfully so. But he also, and I think about the HP connection, and obviously Dr. Branner had a very deep connection with HP. A lot of people ended up at Hewlett Packard up in Santa Rosa. And he would talk about it as the Toy Story in the sky. I don't know if you guys remember that. That's the toy store in the sky. Yeah. You guys remember that? And so we, I had this vision of the thing up in the clouds, and it was, some place to just have a lot of fun and do really, really cool things with magic again. It was a magical sort of a concept. And then he set up a tour. And so we were fortunate to get on a bus one day and work our way over. It's amazing, 30 years ago or more at this point. And it comes back, vivid memories. I remember in our bus ride, Dr. Branner probably remember this, we had to go pick up a guy who didn't quite make it on campus to get on the bus. We took the detour to Vacaville, Chris Plum. Went to his house, picked him up on the made sure he got to go. And so he went with us. We went up there, and we ran into people that actually became sort of like role models for me ultimately. There was a guy named Mike Dethlefson who gave a talk on what a YIG is. He described it, told us about the stuff that happens in HP, in the lower floor of HP up in Santa Rosa. A guy named Dr. Mohammed Saeed, if anybody remembers Mohammed Saeed. Another amazing guy. And put us on the basketball court in the middle on the second floor. I don't remember if you were there, Suresh. Dave probably remembers. But probably a lot of you guys went through the same sort of experience. And the way that Mohammed would go is, he was one of these guys. He says, hey, you guys haven't learned anything yet. We actually had learned a lot, and he'd start throwing stuff at us, like, tell me the gain of that thing, and tell me, like, what did you design? It's like, well, we designed an amplifier. Tell me the gain of that thing. Tell me the P1 dB. Tell me the PSAT. He threw a whole lot of industry language at us. We didn't really know all of it, and he said, go back to school. That was sort of the Muhammad style. But anyway, the whole experience is incredible. After I graduated, Dr. Branner was the one who connected me to some folks at a company called Spectrion, and I went to work there for a little while, and that was a good time. But HP was the place And so it wasn't long after that HP had opportunities, and Dr. Branner was like, you should apply over here. And I did, and probably didn't have to do a whole lot because I had his endorsement, but I went through that process, ended up at HP, ended up actually supporting a bunch of network analyzer type products. And the first time I saw Trang's name was because she was probably 2 or 3 years ahead of me, and she had been there supporting some of the same products before I got there. She'd gone to the dark side, I think, for a little while there. Just some software sort of, you did some software, right? Software. Yeah. So, but she was on the 8510, and then she came back to RF later. But anyway, all of this was early in the career, and it turned out to be pivotal for me. And it was really all set in motion by Dr. Branner. And all the way through my career, as I think about it, every step of the way, effectively, he's been there. Sometimes, you know, like we're not talking all the time, but I've always known he's there. And the amazing thing about that is, like, for me, I'm just one out of all of you guys, and this isn't even everyone, right? But somehow he kept track of all the people that came through. I don't know how he did it, and I don't know how he does it. But I do remember this. I guess I'll say it because I'm here and might as well. I remember him saying, if you didn't do well in my class, don't ask me for a referral. And I remember, like, boy, that's tough, but he was absolutely right. And I've used that too, actually. Like, if you're somebody that hasn't done well, or wasn't performing the way you should have, I'm not giving you a referral. You're better off not without my referral. And he was the same way. He was like, you don't want my referral because it won't be the right referral. So, but so many different things stuck with me from this period through my career. Like I said, this is personal, so I'm giving my personal story. This may or may not relate entirely to all of you, but to some of you, bits and pieces may relate. The memories are fantastic. All the way through, I have always, like my wife has heard Dr. Branner's name so many times at this point. My kids. Sure. And so they know the impact he had on pretty much every step of my life. And like I say, it's not just a career, the professional side, but it's the personal side, and so many others. So it's amazing that we had this opportunity. It all started out with just randomness for me, probably for everybody in some way. You ended up in this thing, and you became part of something really, really important. We're really fortunate, and so I feel that way, and I'm very happy to be here with Dr. Branner here, and I really want to just say thank you for everything you did for me and for all of us.
Oh, thank you, Jen. Thank you. Okay, so we are going to continue with our guest speakers. Our next guest speaker is a system architect and 6G technical lead at Keysight, and also happens to be one of my old 132 classmates, so we spent a lot of time studying together, Cameron Blatter.
They're both here. Hi, Prof. Branner.
Good to see you.
You too. So we have one more report to give you. So if you had, these are circulating around, you know, it's a thank you card, but just remember the honor system. You know. Okay. So I put together some thoughts that, you know, I think resonates with a lot of people here. So I thought, you know, thinking about, you know, where we've come, you know, how we got to where we got to, and you know, I was a student that took Professor Branner's undergrad courses, 132, and all of his graduate courses as well. So I was very fortunate to have all those experiences. And today I'm deeply grateful for, the opportunity to express my gratitude today. And, I came from a modest background, from a family. I think, we all kind of fell into these courses like Jen was talking about, sort of randomly. We sort of said, I'm going to get to UC Davis. Great. Okay, what should I? Oh, engineering. Oh, I had some aptitude, some interest in math. Okay, let's try electrical engineering, and I kind of stuck with that, right? So, and you get to learning. You go through your courses, and you learn the sequence of the courses. And I really enjoyed electromagnetics, of course, and so I kind of went down the road, and that fell into 132. And 132 was, as everyone said, very special. There was magic to this class. It was elevated in its excellence. It was, you're learning something that seemed to have more meaning, more relevance. And it was a pivotal moment from that moment on, looking back of, my career, and it was the launching pad for my career, absolutely. And I think a lot of us would be nodding our heads for that. We learned fundamental RF microwave design. People talked about impedance matching, transmission lines, distributed filter design, it goes on and on. But as many people said, the class was much more than that, right? He taught us critical thinking and to scrutinize carefully, careful what you trust. He emphasized the measurement should be questioned. Never trust the instrument perfectly. I still, to this day, profess my slot line was bunk. So equally important, Professor Branner he cared, right? So that was also stood out, right? I remember in class how we would be furiously scribbling down our lecture notes and trying to keep up. And, at the end of it, as you're catching your breath, he would be sitting there smiling and a little chuckle. I still remember that a lot. And you knew that, he was pushing us hard, clearly, and he believed in our potential. Professor Branner cared not only that we grasped the material, but we were truly prepared for the real world. And not only did he, he cared also just sincerely, how we did in the future in our careers. I mean, he really did. So we left his class with confidence in, achievement, absolutely. So it's clear your decades of investing in people, or what you would call dollar cost averaging, has paid off. I mean, here's the people to prove it. QED, right? QED. All these people here. Decades of teaching people. And I would also just say that, your bold initiative of starting undergraduate RF microwave training course was, if we go back in the day, was, a new thing. It was not something done at undergraduate level. You were one of the first, if not one of the, maybe the first, right? So, I think that has led to, certainly a pillar of strength for UC Davis, the EC department. The EC department has a lot, I think, has grown in this department. And, I think some of your teaching and building this program has really led to that. Your classes always taught me about hard work, and you've exemplified that over 47 years of teaching. It's amazing, as a second career. So, and as I understand, just like many of your lectures would end, to be continued. So I hear you're still teaching, so that's great. Let's continue that, and I really want to thank you for all that you've done for us.
Thank you. Thanks, Cameron. Okay, next, we have Suresh Ojha. Suresh is the section manager for signal sources at Enritsu, and for those of you who don't know, he's a very avid supporter of the 132 course and a friend of the Branner family. Suresh.
Thank you, Jesse. And you know, the other thing that's really excellent about this event is the opportunity to see so many really wonderful friends in one location. And Dr. Branner, you know, that's, as Cameron said, that's a testament to you. But before I start, I have a brief presentation that I wanted to share, just one story of Professor Branner's impact. I wanted to first be kind of true to my South Sacramento roots and mention that when I was a sophomore in high school in journalism class, this wonderful man showed up, and he was a community activist, and he was working really hard to make sure that we didn't see the impacts of the Bloods and the Crips in our neighborhood. And when I was a senior, I had received this letter in the mail from UC Davis saying, just randomly, you know, you've been assigned to Professor G.R. Branner as your undergraduate academic advisor. And so this gentleman drove me home after a community meeting, and he said, well, I'm really glad you're going to UC Davis. And he said, do you know Professor Rick Branner? And I said, no, not personally, but I got this letter that he's been assigned my undergraduate advisor. He said, well, that's my brother-in-law. He's married to my older sister. And so that was Mr. Ed Elmore. Another story that I wanted to share is that same summer, as I was getting ready to start at UC Davis, there was a gentleman, his name was Mr. Danny Nunn. He was a Tuskegee Airman. And so this was long before the days of the internet. And he was a ham radio operator, like I'm a ham radio operator as well. And Mr. Nunn said, well, you know, that black professor doing research in RF at UC Davis. And Mr. Nunn had never met Dr. Branner, but he was exceptionally proud at that time, Tuskegee Airman who had served his country. He knew of Dr. Branner, and Dr. Branner, you never personally met him, I did, but I wanted to communicate that affection that he had for you.
Great. They were my heroes.
The story that I want to kind of share is another impact that Dr. Branner has had, not just on my life personally, but on an entire nation. And so I was born in Nepal, and when I had an opportunity to do so, I tried to reestablish the 132 series in Nepal. And that was a challenge in itself. And like many times, as Jin said, my wife, my son, they've heard Dr. Branner's name so many times. I always leaned on him for advice on how to manage it. And so a couple things. I stole his idea of the 132 series to replicate it in Nepal. Not only that, but I stole his donors. And so at the time, I used to work for Keysight, Agilent at the time. And so I want to mention another person who was seminal as a mentor to me, another Branner graduate, Mike Dethlefsen. Mike Dethlefsen and Rod Sugiyama were key in securing this donation. So I went to Dr. Branner, and I went back and forth to Davis personally multiple times and spoke to him on the phone. And Dr. Branner told me, Suresh, this is a really bad idea. You know, you shouldn't do this. And so Dr. Branner had heard about my father, and that many times we didn't see eye to eye, although we loved each other dearly. He said, what does your father say about this? I said, well, he called me an idiot. Dad said, you're going to go to a country where you don't speak the language very well, where you're going to have to bribe officials to get anything done. Nobody's going to appreciate what you do. And so Dr. Branner brought it home. He said, okay, who's going to pay for your electricity, your water bill? Are these people paying you? I said, no, I'm doing it on my own saving. And he said, he told me, okay, I'm not sure I'm going to help you, but I want you to do the compounding interest special problem. Okay, do it again. But this time, I want you to do it by calculating the engineering income that you would have lost compounded to 20 years from now. And tell me after that whether you still want to do this. And so I said, Dr. Branner, this is something I really have to do. And if I don't do it, because, who else would? And there are hundreds of millions of dollars being spent in Nepal and countries like Nepal to try to uplift it out of horrible poverty. Nobody's doing engineering training for the nation. And somebody comes to the nation and says, my product is right for your wireless infrastructure. How do they know whether that's true or not? You have to have that background to be able to make that decision. And so I went ahead and I lived in Santa Rosa, again, kind of the Toy Story in the sky, working for Agilent at the time. And I went to Yardworks, and I needed some teaching material. And I had a wonderful set of donated lab equipment from Keysight, but I needed something else. And I remember the slotted transmission line lab. I got some sheet metal and a zinc rod, put it with some N-type connectors, and I built a beautiful transmission line that had maybe 25 dB of return loss and wonderful insertion loss. And then I took a Schottky zero bias detector, and by putting mismatches, you could see the standing wave. And so I took it to a good friend of mine, a wonderful technician at Keysight named John McCann. And I said, John, will you measure this for me? And John was a great technician, and he said, Suresh, this looks really goofy. It's ugly, but it works really well. So I took it to Dr. Branner, and I showed it to him. I said, hey, look at what I built. I have no money, but at least I have a slotted transmission line. And he looked at it and he said, this is terrible. How are you going to teach with something like this? It's not repeatable. You got to do it again. So crestfallen, I went ahead and did improvements to that. And actually, it worked wonderfully. So thank you for that, Dr. Branner. It was painful to hear, but appreciated it. So I want to talk about, once I had Dr. Branner's blessings, and support, but more importantly, his lecture notes. And he actually gave me a lab report to take with me to Nepal at that time. And I thought I had won the lottery at that time. And so I'm going to go ahead and share some photographs that show the long-term impact of this visionary professor and how we were able to duplicate that in Nepal. So we established the lecture in the labs. And this was my office for 14 months, the Department of Electrical Engineering at Thiruvan University Bulchok campus. And these were my students, the first lecture that we had. And many months later, they still kept coming, even though as 132 can be kind of difficult, thinned out a little bit, but they were there. And one of the things is, a lot of industry working professionals were auditing this class because they realized that they didn't have a background to go ahead and do that. So this is me giving a lecture on transmission line theory. So this is our first lab. It was the transformer lab. And so Keysight was very generous and they donated ADS. And in addition to multiple VNAs and spectrum analyzers and power meters. And what is an Anritsu guy doing praising my chief competitor? Right? Well, they're a good company, but hey, so are we, right? But they're a great company, and they didn't have to do this. They chose to do it. An employee who's actually going to leave the company, they chose to do it. So, shout out to Keysight. Thank you, Keysight, because I think that was a huge catalyst for me to actually make that decision to go and start this class. So the other thing, as we've seen, is Professor Branner has a huge relationship with industry. He was somebody who worked in industry. He knows how project decisions get made. He knows how people advance. He knows that management doesn't always know the right thing. And he would always say to us, your professional reputation is everything. And one of the reasons, I always joke with Cameron, because Cameron and I do the same thing in opposing companies. But we're always together, and we even worked on some of the same circuits probably, because he went to some of the same companies that I had just left. But that's the Rick Branner way. You fight like hell on the playing field, but then you shake hands and have a drink with your buddy afterwards. And that's the Rick Branner DNA. Personal ethics is corporate ethics. That's one of the things that he always shared with us. So in establishing relationships with industry, this is a repair lab from Nepal Telecommunications Corporation, the largest provider of mobile telephony in all of Nepal at the time. And so I went to this lab. I was actually supposed to go to a repeater site. They were going to fly me in with a helicopter in a mountaintop, but the repeater was blown up that very week by Maoist rebels. And so they said, well, we're not going to take you there, but we're going to bring you here to our repair center. And so these are some of the equipments that were there. And I just realized this like 2 days ago. There was an Enritsu repeater checker that was over there. So shout out to my company as well. I was very pleased to see this. So I gave several lectures to the Nepal Telecommunication Corporation. And so this was the engineering chief staff, and with a picture of the king and the queen in the background. And so he was the director of NTC, Anup Regmi, and he really appreciated that I was there delivering lectures not only to students, but also to his engineers. So at the end of 14 months, we had an inauguration ceremony, and this is the vice chancellor of Tribhuvan University. And the inauguration of our lab was done by U.S. Ambassador Michael E. Malinowski. So a lot of really high-profile government officials as well as university officials came. And one thing that's kind of interesting, we Nepalis have an interesting hat that we wear. It's called a Nepali topi. And I always wondered, why that was shaped the way it was. And I asked one of my relatives, and they said, well, because the mountains are the hat of our nation, so our hats have to be shaped like mountains. So if you see a hat like that, that's why. So this is Ambassador Malinowski presenting a 26.5 gigahertz of DNA by Keysight to the Vice Chancellor. And Ambassador Malinowski asked me a very interesting question. He said, what possessed you to do this? Okay, my Nepali is better than yours. And why would you do this? And I said, sir, it wasn't me. The inspiration came from my professor. I'm just applying it within the context of Nepal. And so I gave a presentation about the state of Nepali technology and the role of RF and microwave during that time. And so these were, the gentleman in the front was the chief technology advisor to His Majesty. The second one in the front was a high-level official of the Nepali Congress Party. Mike Gill is in the background. He was the director of the U.S. Fulbright Commission. So this is a big deal for the U.S. Embassy that this class had been firmly established in Nepal. So this is my class posing. The gentleman sitting over here, this is Sanjeev Pandey. He was my top student. He completed his PhD in Japan, and he went back and he teaches that course here. And he's also an active ham radio repeater, or ham radio evangelist, and he set up after the 7.6 Richter scale earthquake in Kathmandu that destroyed the nation in 2014. He and his team set up a repeater immediately after that. So, wonderful guy. This is Ambassador Malinowski and my students. So this is my beautiful wife, Mrs. Branner, Dr. Branner. She very much wanted to be here today, and she offered her apologies that she was not able to. Both she and my son wanted to attend, but unfortunately they were not able to. But they send their love. So, what were the long-term impacts? To really understand this, I have to give some background first about Nepal. It's the birthplace of the Buddha, or as we say in Nepal, Lord Buddha. This is the exact location, and so you can see for fans of Indian history, that is the pillar of Ashoka. So this is village life near Lumbini, where Buddha was born. And so I took these photos. And this, Nepal is obviously home to Mount Sagarmatha, or in Tibetan, Chomolungma, Mount Everest in English. And this is close to the Chinese border in Lomantang, in a region called Mustan. And I had gone there, it took me 4 days of walking to get there. And it's a beautiful shot, and this is the palace of the king of Mustan, a local regional king. And His Majesty gave me an audience, and I shared with him what I was planning to do with regards to communication in Nepal, and he was very appreciative. So this was the crown prince of all of Nepal, and I had an opportunity to meet him, as well as his father, His Majesty. And he asked me the same question that His Majesty did, that the ambassador asked me, are you crazy? What possessed you to do this? And I said, look, if this doesn't get done by a Branner student, it's certainly not going to get done by any of these agencies that get billions of dollars to try to help from a policy position. And you'll see a lot of discussions on ethnic rights, women rights, LGBTQ rights, and all these things that these agencies advance. And those are all good things. But everybody is elevated when technology improves, and in particular infrastructure. And if it wasn't going to get done by a Branner student, it would never have gotten done. And I think that this is something that policymakers in those agencies and donor industries should really look at as something to elevate the situation of countries similar to Nepal. And why? The wireless technology is really key to the future of the nation, not only because of the mountainous area, but because of the lower cost scalability and multiple G changes rather than investing in hard infrastructure. The scalability and flexibility of wireless technologies are really key to countries like Nepal. And there have been many political and technology changes since 2004. For example, Nepal no longer has a monarchy. It's a huge political change. You can call Nepal now and reach someone with many types of apps, Messenger or whatever. You couldn't do that at that time. It was still challenging. The costs of international calls were really large. Families couldn't connect. But 21 years later, the RF and microwave course is still being taught at Tribhuvan University. We have generations of RF engineers serving the nation. Several of them are actually now in Silicon Valley. A former student recognized me at a community picnic. He said, "Sir, you don't recognize me, but I recognize you." He's now working at Apple. So he was from my first class. So the people in Nepal will never meet Dr. Branner. And Dr. Branner, like Mr. Nunn, you will likely never meet them. But your impact on their lives is absolutely indelible in the entire nation. So I said this to my wife. So Dr. Branner, here's a guy who's as nice as Mr. Rogers. He's as demanding as Elon Musk, probably more so, but with the grace and the humility of the Dalai Lama. And Dr. Branner would always tell us, it's really important how you do things. It's not just whether you get it done, but how do you get it done? It's got to be excellent. It's got to be complete. Just like my slotted transmission line, you can't do it halfway. The other part is how you treat your colleagues matters. People remember. Everybody remembers the old one, the good ones and the bad ones. Do you tell the truth? Do your colleagues tell the truth? Is management telling you the truth when they make a budget for one project or another? How you do it matters. That's the Rick Branner corporate DNA that he's instilled in all of us. And that's not something you expect from an engineering class, quite honestly. But that's something that's helped all of us in our careers, because we ask the same questions that you pose to us in lecture. How you do it matters. And I'll conclude by saying, nicely done, sir.
Thank you, Suresh. Okay, next I'm going to read a statement from, many of you know Dr. Preetham Kumar, right? So Dr. Kumar couldn't make it today, but he prepared the statement, so I'm going to read it on his behalf. Yeah, so for those of you who don't know Dr. Kumar, he's a double E professor at Sacramento State University. He worked with Professor Branner for a long time, and still is. So Professor Kumar says, "First of all, my sincere apologies for not making it in person due to a family gathering. However, on Calvin's request, I wrote down a few lines to be read at this happy event. When I arrived from India to join my student wife in 1992, Professor Branner kindly allowed me to start working in the lab. Though not highly successful at grants, we churned out a multitude of research papers in diverse areas, such as antennas, couplers, power dividers, and mixers. I attended an interview for a tenure-track faculty opening at Sacramento State University in 1999, and it seemed that my chances were slim. However, Professor Branner personally called the committee and recommended me for the position. Though we were in different campuses, our collaboration continued, with Professor Branner including me on several of his students' thesis work and committees, including mine. Hence, I think I can safely state that I perhaps hold the high honor of working with him the longest, 60-plus journal/conference papers in 33 years, and we are currently preparing a reply to reviewers for a recent paper, so still at it. My best wishes to Professor Branner and all attendees for a fun and memorable evening." Okay, next we're going to bring Darren up again for the awards presentation.
Great, thank you, Jesse. Well, I think you've all heard tonight amazing stories. And this plaque, while a motto of all this, it says, "For extraordinary contributions to RF and microwave and education industry," and I think I'll add to that, "to extraordinary contributions to every person in this room who took 132, you've touched their lives, you've changed them in great ways. And I'd like you to come up and accept this award on behalf of the local IEEE chapter, and thanks for your outstanding and amazing career, service, and the person that you are." And I think everyone here would love to hear from you. So now we're going to give you the floor.
I don't know about the time here, and so I have prepared some remarks. I can't go through them all, but there are some that I need to go through, and that is this is all about thanking you, thanking all of you for what you've contributed to this episode here, and to helping me get where I'm trying to go, where I wanted to go, and that is to help people. to help people get where they're going. So first, though, I'm cutting things short because of the time, but I have to thank my wife, Martha. Long and hard hours, managing the family, managing all that we needed to have done while I was away, working at various places to continue to expand and develop my career. And not my career only, but my background, my education, my foundations, like you heard mentioned. And while still being able to get a graduate degree herself, okay? So she has done a magnificent job. I'd like to thank my sons, Kurt, Kent, Craig, and in particular Craig, who worked so very hard for this event to make sure that it ran, make sure that it went properly, make sure that things were right, and very hard and diligently to develop the structure, to help develop, along with Suresh, the structure, and Kelvin, the structure of this event. My son Kent, special for my son Kent, worked very constantly, overtime, and faithfully to see that I have remained safe. Safe. That means on the freeway, and that means at where I am. I'll say no more on that. But, for example, I have a 24-hour surveillance system. I'll quickly want, because of the time, to cut it short. My mother and father, who spent so much time training me, putting me in the right direction, making sure I stayed in the right direction, and a lot involved with that. I wanted to just mention about my grandmother, who taught me to write and read. Even though I was in school, it wasn't going well. It was from kindergarten up. My grandmother had the fortune of being educated in Canada and having a college degree. She was a teacher back in the early 1900s, okay? And that all helped me. And the grandfather, the German descended grandfather, who kept me straight. I say that we lived right down the block from him. Okay, we lived right down the block from him. I have a special things that I want to acknowledge, and that is Richard Kanan. Richard Kanan, who I say is responsible for my first hiring and corporation in Silicon Valley for GTE Sylvania, because there must have been several candidates, and Richard Kanan stood up and made sure that I got the position, and that's the only way I got it. Thank you very much, Kanan. Also for special advice, family advice, and subsequently. And for continued the industrial careers, because it was, they said it was following them around. It was, I went to Electromagnetic Systems Lab, the hint for Dick Kanan, and Harvey E., and I'll talk about Harvey in a minute. And not only the Electromagnetic Systems Lab, but also Argo Systems. I went there because Dick Kanan was able to lead the way and at least provide me the way. Also, importance to me there from the very beginning in California was Harvey E. Harvey E. was a special teacher, a special educator. You heard some people mention, oh, the power of compounding. I keep coming here, I didn't say anything, I didn't know anything. It was Harvey E. pulled me aside and said, oh, they're going to offer you stock. They're going to tell you this, and they're going to provide you this, and so forth. Take it. Be sure you do that. Not only that, special friendship, because once I got here, kaplunk, it took time for my family to get here, and it was Harvey E. and his wife who said, come on, being from San Francisco, come on, we're going to take you and show you around. And they did. They were kind to me. They took me to San Francisco. There was the one story about the botanical garden, which I don't know if you remember, Harvey, so I won't tell you. But they took me all over. And they were my family, along with Dick Keenan. They were my family until my family arrived. These people were very important to me. And the fact that Harvey continued to offer his services to teaching me and making sure I got on board with the business of taking care of people, taking care of yourself in an industrial environment, and as far as handling money, how to handle money properly. And you heard it. 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 I was the kind of person that I wanted people to know. And for a while, one gentleman apparently, I offered the last lecture or two in class. Leonard Bryant, how you doing? The last two people, a lecture in class to try to say, listen, you go out there, you'll grab your money and spend it on cars. You start investing. You start doing it. It was all Harvey E. Okay, so I'll leave it there. And did we make the internet or not? Does anyone know?
Yeah.
Oh, we got it?
Yeah.
Wayne Kelly, I didn't mention. Wayne Kelly was very important to me, and he can't be here today, but he was a very special office mate at the first company, GTE. Very, very special. I counted him as a super designer, a hardware designer, and really a very good friend. Very good, but he was the best designer of that kind of equipment that I knew about. I mean, I'd never seen it. He was meticulous, and he had to have things right. So anyway, I wanted to mention Wayne Kelly. Now, I'll take a brief pause because I'm still in the room, and apparently I'm still talking. 49ers. For 49ers, because I enjoyed being around friendly people. You know, if you didn't want to be around me, fine, don't be. I didn't want to be. I enjoyed being friendly people. And every time I went to the 49er game, I always felt surrounded by thousands and thousands of friends. Thousands and thousands. Everyone was friendly. They were in tune. And that was important to me. Very important to me. 3 Super Bowls. Sorry, Craig. I got to go to 3 Super Bowls. And I took advantage of them every time. And at the last one, it was so tense. Joe Montana, I think, in Miami, and we made a touchdown in the last minute or so. It was so intense that at the end we won, and I stood up and says, I don't want to ever have to do this again. Don't do that. And somebody may be listening. Another thing I want to say quickly is very important to me was Yosemite National Park. Very important. Twice a year. For years and years, I've always taken my family up to a point, and then from there, I have been going every year religiously for many years, 2 times a year, at least 7 days a week. many thousands of days. It was a respite for me, spiritually, mentally, and physically, even though I can't make the mountains these days that I used to. All right, well, real quickly now, I'll move on to, I wanted to mention my thanks previously to the previously mentioned people, to Gustav Medicus, Paul Scheibe, Ed Meyer, and Defense Secretary Perry, because I think that those people were very, very instrumental in getting me through, in helping me through, helping me understand what it was about. You know, it wasn't about me. So, education, opportunity. And then I want to bring out a special person, Dr. Jerry Woodard, who's not here probably, and Mr. Bill Reese, who is deceased. These guys basically rescued me at one point in my career by giving me a very valuable and interesting area to work within. And I'm very thankful to them. So all these people, very thankful to them. Now, I want to be thankful here to Dr. Giovanni Anderson and Dave McQuaid, her husband. These people went to great efforts on my behalf to acquire much of the equipment, to help me acquire much of the equipment, to help me convince Agilent, or what was it then? It was HP then?
It was HP at the beginning,
to help my teaching efforts, to add to all that. Great efforts to do that. And responsible for a lot of those instruments that many of you have experienced and used in the lab. So I want to thank them very, very much, and their constant friendship through the decades. To me, friends are very important. I don't want to be around people if they aren't going to be friendly. Try to treat people well. Try to treat other people fairly and nicely. It doesn't, it's not part of me. It's not part of me. So thanks to Dr. Giovanni Anderson and Dr. David McQuaid. So I'm still being able to talk up here, but here comes the main thing. These guys. I want to thank former graduate students, Suresh Oja, and who kindly seeing over and being keenly aware that of my reputation and overall well-being were conserved. Thank you, Suresh. Greatly appreciate it. And for making things happen so that my efforts would be recognized and understood. Thank you again, Suresh. And for Dr. Kelvin Yu, who has been so instrumental in many, many ways, up to the point where when my P&A, it was the Keysight at the time, or Agilent P&A, had died, organized an effort out of his own pocket, some of it, and out of his corporate sponsors, and put my P&A back on the air. So I have my P&A up and running now, and so forth and so on. So thank you, and a lot that Dr. Yu has done over the years. It wasn't that many years, was it?
Kind of.
Now, also, I want, and here, I wanted to thank my pastors. As my son mentioned, I try to be close to my religion, very much so. And I want to thank pastors, and some of these names you won't remember, but George Lucas. He was the pastor back during my childhood, upgrowing, and so forth and so on. Gardner Taylor. When we lived in Brooklyn, we used to have to take a bus down to what was called Bedford-Stuyvesant. Probably none of you ever heard of Bedford-Stuyvesant. It's the Harlem of Brooklyn. And we took a bus down there to hear this famous pastor. And that was a very influential man for me. And above all, Dr. Archer Summers. Dr. Archer Summers. I can't go into all of that, of all that he meant to me, of all that he spent hours with me. Dr. Summers was a special man. Not only did he have 2 PhDs, he was a lawyer. He had a law degree. So he spent hours and hours and hours with me. Every week I would spend time with him. So and currently Pastor Duncan, who, if you got the word, maybe can view this on the internet. I don't know. I hope she got the word. So thank you all you people. Thank you very much. And wait a minute. A student by the name of Thomas Faulkner, who said, he was up in Washington State. He says, hey, there's no way, who is long retired. He says, I can't make it. He says, why don't you do the internet? That's why we have internet, if it's up and running, as we hope, now, because of Thomas Faulkner. And finally, I want to thank all people who took 132. Thank everyone who took 132. Why? For permitting me the privilege of being able to teach you, of being able to be your teacher. Thank you. God bless you. All right. That's all I got. Oh, thank you.
Oh, thank you so much, Professor Branner. Let's get one more round of applause. Thanks, everybody. So that concludes the official portion of the ceremony tonight, but I hope you can stick around. I don't know if they're going to kick us out or what, but I hope you guys can stick around and catch up. There's a lot of people here. A lot of reunion to do, yes. Thank you so much.
Thank you.
Oh, yeah, that was great. And for those of you who still have not picked up a card, there's a commemorative card that we produced for today, so please take one before you leave. Food, if there's still food out there, we can keep eating it, but the drinks are long gone. But thank you again for coming. Also, one more thing, if you want to take a picture with Professor Branner, we are arranging that, all right? So past students of Professor Branner, please congregate, and we will do the photo together. Yeah, so we'll do it up to the front. Yes, yes.